Hi, my name is Paul Mason, and I'm going to speak a little bit about Uranus. And the planet Uranus was discovered by William Herschel about 160, 70 years after the telescope was first used for astronomy, but is really only a little bit fainter than the naked eye. And so it was found using a telescope like this by William Herschel, and he was able to see that it was a small disk, not a stellar image, and though much smaller than the planets Jupiter and Saturn. But he was only convinced that it was a planet after watching it move among the stars over a number of different nights. Now, we don't know too much about Uranus from the time between William Herschel's observations and the modern time, because Uranus is pretty remote and difficult to observe. The different moons were discovered, several moons were discovered, and they're not very large moons, but it wasn't until Voyager 1 and 2 were launched and flew by first Jupiter and Saturn. We can see Voyager 1's path taking past Jupiter and Saturn in 1979 and 1980. It flew on out of the solar system and has now left the solar system. Voyager 2 flew by Jupiter and Saturn also about the same time, and then by Uranus on the 24th of January 1986. And so almost everything that we have in terms of close images of Uranus occurred either from this flyby in 1986 or by space telescope, Hubble Space Telescope observations after that. And there have been no other dedicated missions to Uranus other than this one. It was just a flyby. So we can see the pictures of Jupiter, Saturn, Uranus, and Neptune all shown here to scale. And we can see the distinctive difference between these two that are often called twins, very similar looking, and Jupiter and Saturn, which are significantly bigger. And there are some very significant differences between these groups. Uranus is very unusual among the planets, unique in some sense that its rotation axis is tilted nearly perpendicular to its orbit around the sun. So if we look at Uranus and how it spins, it would spin like this in the sunlight coming in from the left, as this picture demonstrates. So the Earth is also tilted, but the tilt of the Earth is 23.5 degrees, and this accounts for the seasons on the Earth. Uranus's tilt 97 degrees would mean that its seasons are very much dramatically increased. You have regions at the south pole of Uranus that don't see light for 42 years, and at the north pole as well, and alternately they are in light for 42 years, which is half the time it takes for Uranus to orbit the sun, which is 84 years. We can see that tilt here. This is a natural color image of Uranus. Here is an enhanced color image, and we can see that that enhancement shows the polar region It is heated by the sun. It is because it's always in the sunlight in this image. Aurora were observed by Uranus with the Hubble Space Telescope. We can see also rings here. The aurora indicate that there is a magnetic field, and the rings you can see are nothing like the rings of Saturn, but except that they do have some bright parts which are indicating that we have ices there in those rings and the ring arcs of Uranus. So the internal structure of Uranus is there's a core of rock in the center, something like the crust of the Earth and maybe the interior of the Earth as well. We have rock, iron, nickel, and in a mantle surrounding that core, water, ammonia, methane, and these are in the form of highly compressed ices, maybe some ice mixed in with the core as well. Above that, in the atmosphere is mostly hydrogen and helium with some methane, and the methane in the atmosphere is what produces the color that's very distinctive of Uranus. In this image here, we saw that as Voyager flew by Uranus, there were very few distinctive features, only the green or bluish green kind of appearance, and that color comes from the methane in the atmosphere of Uranus. Above that, we have upper cloud layers, just thin clouds above that. We can see that Uranus is a few times the diameter of Earth, and with as much water as it contains several Earths worth of water within the mantle of Uranus. Highly compressed water, ice and ammonia and methane ices as well. So really, to summarize, Uranus has a magnetic field, and it has a hydrogen and helium atmosphere. It has a core that is made of rock, very similar to the Earth. In fact, the core may be about the mass of the Earth or somewhat smaller. Enormous amounts of water, probably about half of Uranus is water, about a quarter of it is rock, and about a quarter is methane. The atmosphere has a cloud layer, but the main constituent of the atmosphere is hydrogen and helium. So Uranus differs from Saturn and Jupiter in that it doesn't have quite as much hydrogen and helium, but does have significant amounts of water. And so that's Uranus in a nutshell.